Hi guys, today we are going to be graphing rational functions. We are going to graph them by finding all the characteristics by hand or algebraically, and then we will use our technology or graphing calculator to complete the sketch. So let's go ahead and do this. So the directions read that we are to find algebraically the x and y intercepts, find all asymptotes, so vertical, horizontal, and slanted, and then we can use our calculator to complete the sketch. But I need a comprehensive graph, so don't just graph it on. Don't just copy what you see on your screen. You need to include the graphs of the asymptotes. Asymptotes, sorry, are straight lines. So it would be nice if I do see straight lines. So I kindly ask if you please use a ruler or straight edge to graph the asymptotes. Okay, that's enough of my fake finger. Bye. Cool. All right. So coming to our problem. So I need you to find everything that I just read, x, y intercepts, all asymptotes, and all that good stuff. To make it a little bit easier to have this organized, I made those things a fill in the blanks, which is kind of nice in a sense that it's kind of like a check mark. So it's like, okay, I have to find the x-intercept, I have to find the y-intercept, I have to find the vertical asymptote, horizontal asymptote, and slanted asymptote. If some of these don't apply, please don't leave it blank, because I really don't know if you left it blank because of one or two reasons. Either one, because it doesn't exist, or two, you just didn't know how to do it. So if something doesn't apply, just go ahead, write the word none, and we're good. Now, what should you find first? It's really a personal choice, okay? As long as you answer all the questions, you're good. With your permission, I'm gonna go ahead find the vertical asymptote first, okay? So to find the vertical asymptote, we're gonna take the denominator and then set that equal to 0. Okay, so let me just go ahead write it out. So we have x squared minus 4x minus 5 equals 0. Okay, so let's go ahead and solve this quadratic equation. So we have a trinomial. The leading coefficient is 1. Fantastic. And let's go ahead factor away. So we're going to throw down parentheses, make sure that the product of the first terms gives us x squared, and in this case x times itself will be a winner. To complete the binomial factors, we want factors of -5 that add up to -4, and I believe that that is -5 and positive what? Yeah, cool. All right, for the grand finale, if a product equals 0, then one of these factors has to equal 0. If the first factor equals 0, then that's going to lead to x equals 5, and if the second factor equals 0, that's going to lead to x equals -1. So let's go ahead and answer this question. So we were trying to find the vertical asymptote. So our made up abbreviation, we're just going to put VA. So we have x equals 5. That's one equation, and then we have x equals -1. That's our second equation. Now, if we were just listing zeros of the function, then I wouldn't need them separate. But in this case, this represents an equation of the vertical line, so I do need the 5 and the -1 separate. So let's go ahead, bring that to our fill in the blank. Okay, so we have two vertical asymptotes. It's okay. We don't have to have just one. So we have x equals 5, x equals -1, and then we'll graph it in a bit. Okay, so what you find next, it's up to you. For me, I like to find either the horizontal or slanted asymptote. So to dictate which of the two am I going to have, well, that's based on the degrees, okay? The degree of the numerator, so remember, degree code for the biggest exponent on any of the variable terms. The degree is 2. For the degree of the denominator, the degree is 2. So the question is, how can I tell if I'm going to have a horizontal or slanted asymptote? So I'm going to focus on slanted asymptote. So from a previous video, we had said that if the degree of the numerator is 1 more than the degree of the denominator, then there may be a slanted asymptote. But this is not the case. So then how about horizontal asymptotes? So we had said if the degrees are the same, then this is how we find the horizontal asymptote. If the degree of the numerator is less than the degree of the denominator, this is how you find the horizontal asymptote. But let me point out the obvious. The degree of both the numerator and denominator are the same, which means that to find the equation of the horizontal asymptote, we're going to say y equals quotient of the leading coefficients for the top and bottom. So let me break that down. The leading coefficient of the numerator is 1. the leading coefficient of the denominator is also 1. Okay, so you're just going to divide the leading coefficients. Quotient of 1 and itself will give us 1. So we want to tell the world, the horizontal asymptote is given by y equals what. You don't have to box your solutions here, unlike we always do, because I did it as a fill in the blank, but if you want to box it here out of habit, I'm all for it. So we have told our readers so far that we have 2 vertical asymptotes given by those equations, and then we have 1 horizontal asymptote. We have said that there is not a slanted asymptote, so just put any form of saying is not happening. Okay, I just write none. So what we need on the agenda is to find the x and y intercept. It's really up to you which of the 2 you want to find first. Me and my OCD likes to do things in alphabetical order, so with your permission, we're gonna find the x-intercept first. Now, the books will say, oh, to find the x-intercept is given by the zeros of the numerator, which is true. It's absolutely true. But I feel like when I say that, I kind of feel like it forces me to remember a new fact. So whenever possible, I try to memorize what I have to and digest or understand as much as I can. X-intercept, what is that? X-intercept is point where the graph intercepts the x-axis. So if we had an x-intercept at 1, value of y is 0. If we had an x-intercept at 6, value of y is 0. If we had an x-intercept at -7, value of y is 0. So the moral of the story is, no matter where we are on the x-axis, the value of y has to equal 0. So to find the x-intercept, we're going to let y equal 0 and solve for x. And that's the strategy that I'm going to use because that's what we did when we were graphing lines. But if you're like, nope, I have no time for that, then just go ahead and memorize, find zeros of the numerator. So let me just go ahead and speak to myself. So to find x-intercept, I'm going to write down what we just said. Let the other variable equal 0 and solve for x. And this is not because Tori said so, it's because it comes from the graph, okay? Doesn't matter where I am on the x-axis, value of y is 0. So let's do this. Where's the function? So we have f of x is equal to x squared minus 4x plus 3. That's all over x squared minus 4x minus 5. Sorry, my hand is in the way. Cool. So to find the x-intercept, we're going to let y equal 0 and solve for x. So again, you show what you need to show me. Okay, it just depends how comfortable you feel with this material. So we know that f of x is just another name for y. So in this case, we let y equal 0 and then solve for x. So let's go ahead and write down the right side. And you work your magic. Again, I know that you and mental math get along great, but me and mental math don't get along, so I'm going to show a lot more work. So at this point, I want to solve for x. I want to get rid of the denominator. To get rid of this denominator, let's go ahead and multiply it by both sides. So to get rid of the division by that polynomial, let's go ahead and multiply both sides by the denominator. Where am I? Times x squared minus 4x minus 5. Let's go ahead, have good notation, wrap this up. Cool. So yeah, you cannot see that. Sorry. Let me zoom out. Okay, fantastic. So when we multiply both sides by the denominator to get rid of it, product of 0 and this bad boy will give us 0. Quotient of this polynomial and itself will give us 1, and that will give us x squared minus 4x plus 3. So when you find the x-intercept, you can do what we just did, or you can just be like, you know what, I'm on it. To find the x-intercept, I know that I just have to find the zeros of the numerator, and you can go straight to this. It's really a personal choice. So let's see if we can solve this by factoring. I'm going to assume that we can until we realize that we can't. So if it is factorable, let's go ahead, throw down parentheses, focus on getting the first term. Product of the first term should give us x squared, and to complete the binomial factors, we want factors of 3 that add up to -4, and that will be -3, -1. Cool. So if a product equals 0, then one of these factors has to equal 0 according to the zero factor property and your coolness. If the first factor equals 0, that's going to lead to a 0 of 3. If the second factor equals 0, that's going to lead to a 0 of 1. Okay, so x equals 3 comma 1 doesn't really mean that the x-intercept is at 3, 1. So I'm just going to write at 3 and 1. I'm going to write x-intercept equals 3 and 1. So I'm going to box it out of habit, but to get the credit, we do it in the space provided. So x-intercepts, we have 2, 3, and 1. If you want to put them in order, you know, go for it. Okay, so let's do this. Okay, so I think to finish off us finding out by hand, well, we need to do a comprehensive sketch, which is need the y-intercept. So y-intercept, what is that? Straight definition: y-intercept, point where the graph intercepts the y-axis. So the question is, how are we going to find it? So if the y-intercept was at 3, at this point the value of x is 0. If the y-intercept was at -5, x value is 0. So it doesn't matter where I am on the y-axis, value of x equals 0. So the moral of the story is this: to find the y-intercept, we're going to let the other variable equal 0 and solve for y. So let's go ahead, speak to ourselves. Y-intercept, we're going to let the other variable equal 0 and solve for y. Okay, so let's go ahead, start off by writing out the function. So we have f of x equals x squared minus 4x plus 3 over x squared minus 4x minus 5. I'm going to go ahead, replace f of x with y for old time's sake. Yeah. So we're going to let x equals 0 and solve for y. Sorry, my accent gets in the way. Alright, so we have x squared, which we're saying x is 0, minus 4 times x, which is 0, plus 3. That's all over x, which is 0, minus 4 times x, which is 0, less 5. And then you can do a lot of this in your head, I know. Square of 0 is 0, product of 4 and 0 is 0, and that will leave us with the 3 in the numerator. Square of 0 is 0, product of 4 and 0 is 0, and that will leave us with the -5 in the denominator. So we want to tell the world that the y-intercept is given by -3/5, or you know, the decimal equivalent, which is -0.6. So for the grand finale, let's go ahead, pencil it in. Sorry for that really long negative. So we have touched base on everything that we needed. So we are going to use this information to do a comprehensive graph. So we will graph the x-intercepts, we will graph the y-intercepts, we will graph the vertical asymptotes, we will graph the horizontal asymptote, and there is no slanted asymptote. Once we have that filled in, then we're going to punch it into our calculator. So let's go ahead and do this. Okay, I think I can project everything. So our x-intercept, where am I? I'm trying to see which pen projects best. I'll use my red one. So the x-intercepts are at 3 and 1. So we will do a point at 3. We will do a point at 1. Our y-intercept is -3/5. Use your best judgment, you know. So that's about 3/5 away from 0. So I'll just say it's about there. Am I gonna be like, no, that looks like, I don't know, 3/4? Same difference. Okay, they all look the same given the such small area. The vertical asymptote, so we have a vertical asymptote at x equals 5 and 1 at -1. So we're going to do a vertical line at x equals 5 and 1 at x equals -1. So I'm going to do a point at x equals 5 because I need a marker, so that way I know where we do our vertical line. Okay, so let me go ahead and do our vertical line, but we're going to make it a dashed line because the asymptotes are not necessarily part of the graph. They're not, okay, but we use them as markers. Okay, so I'm not sure if that's gonna stand out, so let me use a highlighter as well. So that way we do the asymptotes, in this case the vertical asymptotes, just so we know that the graph comes close to this vertical line, but it actually never intercepts it. Okay, so we have our vertical asymptote given by x equals 5. Let's do the vertical asymptote given by x equals -1. So let's go ahead, locate a -1 on the x-axis, and then we'll do a vertical line right there. We'll take our straight edge, so bear in mind, straight lines, it will be nice if they are actually straight. Okay, the only way that I'm going to ensure that they're straight is if I use my straight edge. So again, I'm going to use a highlighter because I'm not sure if the pen, you can see it off the camera. Cool. Alright. Cool. Alright, so we have graphed the x-intercepts, we have graphed the y-intercept. Cool. We have graphed both vertical asymptotes. What we need is the horizontal asymptote. So the horizontal asymptote is given by y equals 1. So let's go ahead, locate positive 1 on the y-axis, and we'll do a horizontal asymptote through there. So we have 1 on the y-axis. I'm going to have to definitely rotate my paper. Okay. So let me go ahead and do my vertical line. My horizontal line. I'm not nervous. You're nervous. All right. Okay, so we just make it dashed, and again, in an effort for you to see, what I'm writing, I'm gonna use a highlighter. Cool, fantastic. Okay, so again, we have graphed the intercepts, the vertical asymptotes, and the horizontal asymptotes. We had said that there's not a slanted asymptote. So in this case, I want to point out that we have some points graphed explicitly right here in this region. So I'm pretty sure we're going to start curving in here. We will come close to the vertical asymptote, but never intersect it. Now, what about this space, the rest of the space? I don't know. This is why we have technology. Okay, so let's go ahead and use our calculator. I don't think I didn't clear it for you. Oh, I feel so bad. Okay, so the popular mistake, I'm going to show you the wrong answer, okay, so purposely, is x squared. Why am I showing you the wrong answer? Because I've seen this too many times. Okay, x squared minus 4x plus 3 divided by x squared minus 4x minus 5. And our math says that we should have a x-intercepts at 3 and 1, or 1 and 3, and a y-intercept of negative 3/5. Let's go ahead, hit graph. Okay, this is wrong window. Sorry, I didn't do housekeeping. Sorry. Let me go to standard viewing window, zoom 6, and let's go ahead confirm. Well, I told you that I said it wrong. Okay, well, this graph does not appear to have x-intercepts at 1 and 3. Okay, that's almost 1, but not exactly, and 3 is right there. So the question is, what happened? Did I do the math wrong? No, of course, we're cool like that. We know we did it right. I'm going to tell you what happened. Okay, so our problem reads, take this numerator and divide it by the denominator. But look at how I wrote it. Okay, the only thing that I have before the fraction bar or the division key is the 3, not the trinomial. The only thing that follows the division sign is the x squared, not the trinomial. So in this case, you need to wrap it up. Please don't do that. So let's go ahead, open the numerator, then punch it in. So we have x squared minus 4x plus 3, close the numerator, divided by, open the denominator. So we have x squared minus 4x minus 5, close the denominator, and then we hit graph. Cool. So look at that. How beautiful is that? So it kind of looks like we have an x-intercept at 1. Let's zoom in. Okay, let's zoom in more. All right. Okay, just kidding. That's as big as we can get. Okay, so I try to line up the x-axis. So if we squint really hard, it does look like the graph intercepts the x-axis at 1. It does look like the graph intercepts the x-axis at 3, and we have said the y-intercept was negative 3/5. That's a pretty good estimate. Okay, we said there's a horizontal asymptote at what? You know what? Let's go ahead, graph the horizontal asymptotes. We can graph horizontal lines because those are functions, but we cannot graph the vertical lines because the graph of a vertical line is not a function. Let's go ahead, hit y equals, and we had said that the horizontal asymptote was 1. Okay, let's just go ahead and graph it. So look at that. Okay, so we had said that the horizontal asymptote is given by y equals what, and it looks like the function indeed is coming close to our horizontal asymptotes. So let me go ahead, zoom out so we can complete the sketch. Okay, to the best of your ability, no pressure. I hate graphing. Okay, so I'm gonna go something like this. Cool. So I know that I've crossed through the y-intercept, the x-intercepts, and I'm going to just extend this curve to the best of my ability, coming close to the vertical asymptote, but not intersected. Sometimes due to human error, I cross it by a little bit, but that's okay, as long as you don't make it obvious, like, bam, you went over here. So we come close to the vertical asymptote, but not cross it. Cool. And then on the left side, I'm going to continue the curve. Fantastic. So yeah, that's pretty. Pretend it is. Cool. Now, what about these pieces right here? So remember, we said we have a vertical asymptote at 5. So 1, 2, 3, 4, 5. And that will be this vertical line right here. Okay, so we're gonna come from here and then go all the way down, and again, not crossing the vertical asymptote, and then doing our best to come close to the horizontal asymptote. So depending on how I take the curve, that will determine how this looks. So I try my best. On this side, same thing. We had a vertical asymptote at -1, so we have x equals -1. Let me go ahead and use my straight edge, and then we have that the graph does come close to the vertical line, but it actually doesn't pass it, and it is coming close to a horizontal asymptote. So let's just go ahead and do our best. Okay. So I tried. Cool. Fantastic. So that's not terribly bad. Yeah, it's actually pretty good. Good. So again, when you use your calculator to complete the sketch, students sometimes just want to put the graph itself, but they don't highlight the intercepts, and they don't highlight the asymptotes. So careful. Okay. Thanks, guys. We're gonna go ahead and do another one. Give me a sec. Okay, so let's go ahead and do another one too. Hopefully we'll have something with the slanted asymptote. It's just falling. Okay, so same speech. So we're supposed to graph this rational function, and then we want to find all the characteristics algebraically. Okay, so if you use your calculator, then you have to pretend like you found it algebraically. So you're gonna have to back it up with your work. So what should you find first? You know, x, y-intercept, and vertical, horizontal, or slanted asymptote. That is a personal choice. As long as you find all these 5 ingredients, if applicable, we're gonna be good. So first thing I like to do is find the vertical asymptote. I don't know why, I'm just drawn to that. So to find the vertical asymptote, remember from a previous video we had said we're gonna ask ourselves what makes the denominator equal to 0. So the denominator is x plus 1. We set that equal to 0, and when we subtract 1 from both sides, that will give us x equals -1. So we want to tell ourselves that the vertical asymptote is given by the equation x equals -1. Let's lock in our full credit. Okay, vertical asymptote, x equals -1. What I like to find thereafter is either the horizontal or slanted asymptote. We're not going to have both. To make that call, we look at the degrees of both the numerator and denominator. So the degree of the numerator, okay, the degree of the numerator is 2. The degree of the denominator is 1. Now, when is it that there could be a slanted asymptote? If the degree of the numerator is 1 more than the degree of the denominator, then there may be a slanted asymptote. Okay, slanted asymptote. Cool. So the question is, how will we find the equation? We're gonna go ahead divide by using long division, and we'll take it from there. So we are dividing by x plus 1. And I want to know how many times does it go into x squared plus 5. So remember, long division, we write the dividend in descending order, and then 2, we make sure that there's a term for each power going down. So the degree of the numerator is 2, so we need to have an x to the second, x to the first. We don't have an x to the first, so we're going to put a 0 placeholder. So we have x to the second, x to the first, constant, which is our degree 0 term, and we do have. So plus 5. And let's go ahead, divide, and we'll take it from there. So we have x plus 1 goes into this how many times? So remember, when it comes to polynomials in log division, although we are dividing by x plus 1, we always focus on the first term. So I want to know how many times does the first term go into the first term that I see. I know that you know that x goes into x squared exactly x times. Line it up. So steps for long division: divide, multiply, subtract. Let's go ahead, multiply. Sorry. Product of x and x will give us x squared. Product of x and 1 will give us x. So we had just divided, we multiply, time to subtract. When you subtract, it's really up to you how you choose to show the notation. X squared minus x squared gives us 0, or we say it cancels. 0x minus x gives us, I think, negative x, but don't quote me on that. And the reason why I say that is because it's really hard for me to subtract like this. I really need to distribute the negative or add the opposite, and then I can say it with confidence. So opposite of a positive term is a negative term. Opposite of a positive term is a negative term. How can I make this negative? If you just scratch out the plus sign like this, it's just gonna look like a weird plus sign. So what I like to do, I just circle it and I put a minus on top. That's my style. Okay, so we have just distributed the negative or added the opposite. So let's go ahead and combine. X squared minus x squared with confidence, 0. 0x minus x with confidence, now negative x. So steps to long division. Divide, multiply, subtract. If there's another digit, in this case another term, bring it down. And then we'll repeat the division cycle. Okay, so let's go ahead, divide. So I want to know how many times does the first term go into the first term that we see. X goes into negative x exactly -1 times. And to tell you the truth, we can stop. But for students, I'm going to keep going. So let's go ahead, divide, multiply, subtract, and take it from there. When we multiply, product of -1 and x will give us negative x. Product of -1 and 1 is -1. So we had divided, we had multiplied. Now let's go ahead and subtract using the notation of your choice. Sorry, my laptop is getting really hot, so that's why you have that background noise. Negative x minus negative x, I believe, is 0. 5 minus -1, it gives us 6. It's cool. So if you can subtract like that, go for it. But you know my style. I need to add the opposite so I can be confident in my work. Opposite of a negative term is a positive term. Opposite of a negative term is a positive term. We have added the opposite. Why do we do that? Because that's from pre-algebra. You know, subtraction is the same as addition of the opposite, or in English, distribute the negative. No one will ever know. Okay, so we wrote this subtraction problem as a related addition problem. Negative x plus x will give us 0, and 5 plus 1 is 6. Fantastic. Now, what is the equation of the slanted asymptote? So let me break it down. So the equation of the slanted asymptote is given by y equals the quotient. Okay, y equals the quotient. So in this case, the quotient is x minus 1 and the remainder is 6. But the equation is just, we put the variable y equals whatever the quotient is. The quotient is just x minus 1. So we have y equals x minus 1. That will be the equation of the slanted asymptote. Fantastic. So let's go ahead and earn our full credit. So we have y equals x minus 1, and there is no horizontal asymptote. Okay, so to finish it off, what we need to have a comprehensive sketch is the x and y intercepts. Again, you find whichever one you want to find first, and you algebraically find it however you like. I'm going to use the same style. Okay, so to find the x-intercept, we're going to let the other variable equal 0, and then we're going to solve for x. Or again, you can just do what the book says, you know, find the zeros of the numerator. I mean, you digest it however you like. Okay, so the function reads f of x equals, where am I? X squared plus 5 over x plus 1. What are we gonna do? We're gonna let y equal 0 and solve for x. So f of x is just another name for y. So we're gonna let y equal 0 and solve for x. Okay, so we have x squared plus 5 over x plus 1. To get rid of the fraction, let's go ahead and multiply both sides by the denominator of x minus 1. I mean of x plus 1. Let's go ahead and have good notation. So on the left side, product of 0 and x plus 1 is just 0. On the right side, quotient of x plus 1 and itself is what? And that will leave us with x squared plus 5. So bear in mind, we are trying to find the x-intercept. So let's do this. Sorry. Okay, so work your magic. Let's go ahead solve for x. So we're gonna solve this by using the square root method. So let's isolate the squared part. We're gonna subtract 5 from both sides, and that will give us -5 equals x squared. For the grand finale, to get rid of the square, let's go ahead square root, and then we'll insert our plus or minus. Okay, so that will give us x equals positive or negative, whatever the square root of -5 simplifies to. Now, this is the thing. The square root of -5 is not a real number. It's not that we can't simplify the square root of -5. We can. It's just not going to be a real number. Okay, it simplifies to I times the square root of 5. But the thing is, x-intercepts, they have to be real numbers because we only have real numbers right here. There's no space for non-real numbers. So because x equals a non-real number, then there's not going to be an x-intercept. So there's no x-intercept. There's no x-intercept. Cool. So in terms of how do we phrase it in our fill in the blank, same way we did for horizontal asymptote, we just write none. Okay. It's okay, we don't have to have an x-intercept. Don't panic. And then when we punch it into your calculator, you'll be like, oh yeah, there is no x-intercept. Confirmation. Okay, so to complete the fill in the blank, so we need is the y-intercept. So again, you're supposed to find these algebraically. If you use your calculator, then you need to back it up with your handwritten work. Okay, so let's do this. Y-intercept, point where the graph intercepts the y-axis. So to find it, we're gonna let the other variable equal 0 and solve for y. Let the other variable equal 0 and solve for y. So the function reads f of x is equal to x squared plus 5 over x plus 1. We're going to let x equal 0 and solve for y. So I'm going to replace f of x with y for my peace of mind. We're going to let x equal 0. So let me go ahead zoom in. So that will give us x, or 0 squared plus 5 over x, which is 0 plus 1. Numerator will give us 5. Denominator gives us 1, and the quotient of 5 and 1 is 5. So we want to tell the world that the y-intercept is given by 5. Cool, fantastic. Let's go ahead, put it in place, and get our full credit. Okay, so before we punch it into our calculator, I really need you to graph these items, so the x and y intercepts and whatever asymptotes we may have. So that way when we punch it into our calculator, we'll be like, yeah, it looks like we do have a y-intercept of 5. It does look like we have these asymptotes. And if it doesn't look like that, then I trust our math. It's just like we probably forgot something. Okay, so let's go ahead graph what we can. So we have established that there's no x-intercept. I'm still trying to get over that, but I trust our math. Okay, the y-intercept is at 5. Let's locate 5 on the y-axis. We have a vertical asymptote given by x equals -1. So we're going to locate a -1 on the x-axis and then do our vertical line right there. Please use a straight edge, so we'll make it dashed. Can you see that? Yeah, I think you can, but I'll just use a highlighter. Okay. Alright, cool. So that way you can see it better. Okay, and what else? So we nailed the y-intercept, the vertical asymptote, slanted asymptote. You graph this however you like. You can use a table of values if need be, or you can use the slope and y-intercept. If we use the slope and y-intercept, we have a y-intercept of -1 and a slope of +1. So up 1, 1 to the right, and then you connect the dots. If you're like, oh, I'm having a moment, Ms. Torres. Oh, my identity has been revealed. Okay, it's been compromised. Okay, so if you're like, I'm having a moment, I forget that slope and y-intercept thing, then just go ahead, do a table of values. Okay, so if x is 0, value of y, 0 minus 1 is -1, and you graph it, 0, -1. My next favorite x value is 1. If x is 1, 1 minus 1 is 0, and we graph it. Okay, right there, 1 to the right, stay put. So you graph it however you like. You can graph it by using the slope and y-intercept, or I'll just put it right here. The slope is 1 and the y-intercept is -1. Cool. Or you can use a table of values. I don't really care. Just make sure you graph it. Okay. Let's go ahead. Use a straight edge to connect the points. Again, the asymptotes are not really on the graph, are not points on the graph. Or I don't want to say not really. That's just how I speak. Okay. The asymptotes are not on the actual graph, but we need them in order for us to do a nice sketch. Okay, fantastic. So let me just make sure we graphed everything. And if we graphed everything that we listed, then we are going to have a comprehensive graph. Okay, we have established that there's no x-intercept. We do have a y-intercept of 5, a vertical asymptote given by x equals -1. We have no horizontal asymptote, but we do have a slanted asymptote given by y equals x minus 1. So let's go ahead, punch it in with confidence. Bear in mind, when you punch it in, make sure you wrap up both numerator and denominator. We talked about that. Okay, so I'm not gonna purposely give you the wrong answer. Okay, so let's clear this. Okay, so we have opened the numerator, x squared plus 5. Remember, and close the numerator. Pause and rewind as many times as needed. All over, open the denominator, x plus 1. Close the denominator, and then we'll hit graph. Okay, that's nice, but it would make it a lot easier if I also graph the horizontal or slanted asymptote. In this case, we'll graph the slanted asymptote. So let's go ahead back to y equals, and then the second y, we're going to put y equals x minus 1. Again, we cannot graph the vertical asymptotes because the graph of a vertical line is not a function. It fails the vertical line test. Okay, let's go ahead, hit graph. So look at that. So this kind of, let me go ahead, put it closer. Let me go ahead, zoom in. Okay, that was too much. Okay, so that looks pretty nice. Okay, this looks kind of like our asymptote. We had said we had a vertical slanted asymptote. We had said we had a vertical asymptote given by x equals -1. So let me go ahead, locate -1 on the x-axis and do a vertical line there. Look at that. Okay, so this is exactly how we're gonna do it. We had said there's a y-intercept at 5. So let me see. 1, 2, 3, 4. I think that's 5. My eyes are tired, so I can't confirm it. But yeah, so let's go ahead, do our sketch. So we're gonna do start doing our curve, trying our best to go through that intercept, making sure or try not to pass the vertical asymptote and then come close to our slanted asymptote. So I'm gonna try. Oh, I'm so proud of myself. Cool, I tried my best. All right, now what about the other side? So we have a little action going to the left. So let me go ahead, do a vertical line with my marker at x equals -1. So we're gonna cover it, so it will make it a little bit easier. So then I'm like, okay, so I'm gonna do a curve over here on the bottom, coming close to my my vertical asymptote and coming close to my slanted asymptote. Okay, so I'm gonna just do this however I can. So however I take the curve, that's how steep it's gonna look. Yeah, I try my best. Cool. So I think we're pretty much good to go. That looks pretty nice, and we have graphed all the things that we need. You know, the asymptotes, the intercepts, whatever we have, and I think that's it. Okay, guys. So we're out. Thank you.